we're asked to show a tangent plane at various points to each surface given by the functions below. We will do this using the 3D Calc Plotter JavaScript app shown here at the bottom, and this is from the Exploring Multivariable Calculus site shown here. Let's open up the app and show the tangent plane. When the app is first opened, this is always the default surface it is graphed, given by the equation here on the left. And notice how this is the first function we're asked to graph to show the tangent plane. But to make it clear that the 7xy is in the numerator, let's put the 7xy in parentheses. Notice if we press graph, the surface doesn't change because the entry is equivalent. Next, let's make the surface transparent so we can more easily see the tangent plane. To do this, we click the magnifying glass at the top. Notice now the surface is transparent. Next, we click on the 2D trace plane, which is this button here, then the arrow to the right, and select Show Tangent Plane at Point. Notice the trace plane is the XY coordinate plane. Let's click on a point on this plane. When we do this, the tangent plane appears on the surface at the blue point. But notice right now, the positive x-axis is moving to the right, and the positive y-axis is moving up. Let's change the orientation of the surface so the orientation of the xy plane is the same. Let's rotate this surface so the positive x-axis is moving to the right, and the positive y-axis is moving up in this direction. And now let's animate the tangent plane along the surface. The plane is tangent to the surface at the blue point. So this gives a nice visual of a tangent plane to a surface. Just like we can think of a tangent line as a linear approximation to a curve in 2 dimensions, we can think of this plane as an approximation of the surface at the blue point. Let's graph our next surface, which is given by the function f of x comma y equals 5 divided by e raised to the power of x squared plus y squared. So let's clear this entry and enter 5 divided by, in parentheses, e raised to the power of x to the second plus y to the second. And now we click graph. The new surface is graphed, but we need to zoom out. We zoom in and zoom out using the plus or minus here at the top. Let's click minus to zoom out. And now we have a nice graph of the surface. If we want the surface to be more smooth though, we can change the number of grid lines. Let's change the number of grid lines from 30 to 50 and click graph. If we watch the top of this peak here, it'll become more smooth, which we see now. And now we click on a point in the trace plane. Let's click the point 2, 2, and the tangent plane appears at that point on the surface, and now we can animate the tangent plane along the surface. The plane is tangent to the surface at the blue point. Let's look at our last surface given by the function f of x comma y equals 2 sine y. So we clear this function and enter 2 times sine y. And click graph. Notice how we have a graph of a cylinder. Let's reduce the number of grid lines so we can more easily see the tangent plane. Let's change the number of grid lines back to 30. And click graph. And now we'll click on a point in the trace plane, maybe 2, -2, and now we'll animate the tangent plane. I hope this gives you a nice visual of a tangent plane to a surface. Thank you for watching.